we're going to be jumping into exponents today, which is super exciting. Exponents, like we were saying to our last grade 9 class, exponents, the laws that you learn in these laws now that we're going to be doing in grade 9, and some of them that you did in grade 8, you're going to use them all the way to matric and after matric. Anytime you do maths, they stay the same. So we're going to learn them now, and then they just stay with us forever, which is awesome. Okay, let's quickly deal with these questions, and then we're going to chat. A corner, how can I help? Hello? So we're not going to be looking at rational numbers at the moment. I think Teacher Sam had already done that. Yeah, a corner, how can I help?
Hi, ma'am.
Hi.
Ma'am, just wanted to ask about this, the direct and indirect proportion. In my school right now, we're currently doing it, and it's quite like hard for me. So, ma'am, can you just please, like, maybe when you have some time, let's hop on it.
So direct and indirect proportion is something that Teacher Sam will be covering when she goes through patterns. So don't stress, it is being done. It's just not going to be done right now at this moment, but it will be covered. So don't panic. Okay, when we are dealing with exponents, we have two very important words. We have a base, and then we have the exponent. And sometimes we can call the exponent a power, and sometimes we can call it an index. All of those mean the same thing. So in this situation, the 5 is our base and the 2 is our power or our exponent. So we would say this, if we had to say this as a sentence, we would say that that is 5 to the power of 2. Okay. What does it mean for 5 to be to the power of 2? What does that actually mean? How could I write that out in a way without having an exponent? Yes, Lolita, can you tell me?
It means that 5 is being multiplied by itself twice.
Beautiful. So I'm having 5 times 5. So it is being multiplied by itself twice. Beautiful, beautiful answer. Okay, so if I had 5 to the power of 3, then it would be 5 times 5 times 5. If I had y to the power of 3. So now all we're doing is we're making it a y instead of a 5. So I'm going to say y to the power of 3. All that means is it's y times y times y. Okay, so it's just saying it's that number or that variable multiplied by itself that many times. That's all it means. Now, when we start dealing with powers, we get to learn all kinds of different rules to try and help us and make our life easier. Exactly, it's just putting it in an expanded notation. And some of the things that we're going to do today is we are going to expand. So we're going to make it longer before we make it shorter, just so that we really understand what we're doing. But you'll see what that means now. Okay, so let's have a look at how we can use this idea of exponents and bases and start playing with them in different ways. In exponents, there are a whole bunch of different laws. So we have laws with multiplication, laws with division, laws with powers, laws with distribution, and all of those laws start filling in as we grow in maths. So the higher grades we are, the more we learn about the different rules of exponents. But the first one that we learn about is law 1, which is multiplication. And a lot of you would have done this in grade 8, so it shouldn't feel too scary or too new. But what we are going to be introducing this year is where we're going to have some negatives and some numbers just to make it a little bit spicier. Okay, so there's some very important things that are happening in this pink box. The first thing is that both of those x's, they are the same base. Okay, they are both x's. We are not allowed to add exponents of things that don't have the same base. So if that was x to the power of a times y to the power of b, then I can't do anything. They have to have the same base. Okay. And then these two over here, those are our exponents. If those bases are the same, we are allowed to add those exponents. Exactly. It's kind of like saying they must be like terms. Exactly. So if I'm having a look at an example here, now I've got x to the power of a plus b, sometimes that can feel a bit more confusing. So let's write it as numbers. If I had x to the power of 2, and I'm multiplying that by x to the power of 3, okay, what we're going to do is we're going to keep our base the same. So our base is an x. So we're going to keep that as an x. And all we're going to do is we are going to add our exponents. So we're going to say 2 plus 3, which gives us 5. Now, the reason it works this way is because if we wrote it in expanded notation, it would look like this. These two x's here would be x times x. And these three x's here would be x times x times x. Ignore my little green x, that's a multiplication sign. Okay, and so if I look at my final thing, I've got 5 x's. I've got 2 and then I've got 3. I have 5 x's, which is x to the power of 5. So sometimes it helps for us to write it out in an expanded format for us to see what's going on. But otherwise, we're just sort of adding what those different ones are. We add the exponents on the top and we leave the base the same. Exactly. You leave the base the same and you add the exponents on top. Exactly. Okay. Beautiful. You might want to take a screenshot of this because I think it'll help you as we start going through some of these questions. And we're going to go through a couple and I want you to experiment with them. I want you to remember that in maths, it's a good normal thing to make mistakes. So I want you to try and make mistakes. I mean, not like actively go out of your way to make mistakes, but I want you to give all of the questions a try and do your best with them. And if you make a mistake, it's okay. It's best to make a mistake in these cases, and that's how we learn. Okay, so don't ever be embarrassed to make a mistake or to ask a question. That is what we are here for. So let's have a look. We're going to start with this first one. Now, there's a very normal trap that has been set in this question. I'm going to see how many of you fall for it, how many of you don't fall for it. Let's see. I would like to know what the answer to this question is. Okay, I see the hands. I will call on you. I'm just going to give everyone a little bit of a chance to get there, and then I shall be asking. Okay, Callan, I'm coming to you only because Lolita, I gave you the answer just now. Callan, can you tell me what is going to be my answer to this question?
Evening, ma'am.
Hi.
So basically the answer would be x to the power of 5 times x.
Okay, no, I like that. X to the power of 5 times x. Could I take that one step further?
Yes, ma'am.
Okay. What would it be after that?
So 5 times 6 times 6 times 6. Basically.
Before you overthink it, if I have a number like this x over here, what exponent would it have? Because it doesn't have a number. Exactly. Okay, it would have a 1. So thinking about it like that, what do you think my answer would be?
5. 5 to the power of 1.
So keep your base the same?
X to the power
Yes.
of
Good.
5.
Keep your bases the same. And then what do we do to our exponents?
It's basically we're gonna plus the 2 exponents.
Yes. So
x to the power of 6.
yes, we got there. Woohoo! Nice job. Great. Okay, so guys, you can do this in stages. So what Callan did here was first work out the x squared times the x to the power of 3, and that gave the x to the power of 5, and then we had the x, which was also just x to the power of 1. Okay, so you can do it in 2 steps. Totally okay to do it like that. You can also do it in 1. So you can say, cool, all of my bases are the same. They are all x's. I'm going to put in this 1 over here because I don't want to forget about it. And then I'm going to add my exponent. So I'm going to say 2 plus 3 plus 1. So 2 plus 3 is 5 plus 1 is just going to give me x to the power of 6. Okay. A third option. So option 1, option 2, option 3. If you're feeling completely lost by this, you can write it out in long format. So we have x squared times x cubed times x. So now I put these little x's here. So we've got x squared, we've got x cubed, and we've got x. And if we add all of those x's together, we've got 2, and then we've got another 3, and we've got another 1, which gives us x to the power of 6. So depending on where your comfort level is at the moment, that sort of determines which road you should be going on right now. All right, Sonwabise, how can I help? Hello?
I just wanted to answer number A.
Oh, okay, no problem. Guys, if your hands are up to answer, do you mind dropping them down for me so that I don't think you have a question? Okay. Cool. Sonwabise? Okay. Why do we add the first 2 x's when the third one? Yeah, so you can. So you can add all 3. You can do this one. You can go straight there. All right. Let's try another one. Ah, another Jennifer. My name's also Jennifer. So clearly we have the best name, obviously. Okay. Guys, in this one, we need to be careful because we have got different bases. All right, we've got x's and we have got y's. So I need you to be very careful about what is happening with those different bases. And then I want you to give this question a try. Big welcome to all of our new people. Your normal teacher is Teacher Sam. She will be back with you on Wednesday. I'm just stepping in for the day, just giving you some Teacher Jen energy for your Tuesday afternoon. Is today Wednesday? Did I say Wednesday? Goodness, guys. Am I losing the plot? It's very possible. Okay, Melo, can you help me? Have you got an answer for me? Do you have a question?
Okay. Ma'am, the answer is x to the power 4 and y to the power of 6.
Beautiful, nice job. And so much confidence, loved it. Okay, 100% x to the power of 4, y to the power of 6. Let's have a look why. We've got 2 x's in our first term, then we've got 1 x, and then we've got another x, so that's 2 plus 1 plus 1, that's going to give us 4, and then our y's, we've got 1 plus 2 plus 3, which gives us the 6. Okay, if you're feeling lost by this, please pop your hand up or pop a question in the chat so that I can answer before we move on to the trickier ones. Taba saying, how can I help? Hello? Okay, so the reason it's x to the power of 4, so for those of you who aren't sure where the numbers are coming from, let's write it out the long way. So I'm going to write the different variables in different colors. So I have 2 x's, and then I have 1 y times 1 x and 2 y's times 1 x and 3 y's. Okay, that's the first one. That's the second one. That's the third one. then all we're doing is we're basically adding what we have. So we have 2 x's, then another x, then another x. And so we have 4 x's, x to the power 4. And our y's, we've got 1, 2, 3, 4, 5, 6, y to the power 6. Hopefully that makes that a little bit clearer. Tulisile, how can I help?
Ma'am, I want to understand how you got x to the power n4 and y to the power of 6.
So does what I have on the screen make that a little bit clearer of how you can see there are 4 x's now?
Yes.
Okay, good. Okay, guys, let's try on our next one. Let's see how we can progress our way through this. I want to skip that one for the moment. Let's have a look here. Okay. The difference with this one is now we have got numbers. So we have got constants in front of our variables. And that is when we need to start thinking about SNV. Okay, and I know some of those who have not seen SNV before, you might be thinking, oh my goodness, those are saying sex, nudity, and violence in movies. That is definitely not what we are doing in maths. We are doing signs, and then we are doing numbers and variables. Okay, those are the 3 letters that we think of when we are doing math: signs, numbers, variables. First thing we look for are they positives? Are they negatives? What's our situation? Look at your numbers, multiply them together, then look at your variables, see which your answer is going to be. Okay. Okay. Oh, the only reason we skipped C because I thought we'll come back to it. Don't panic. Jennifer, have you got the answer for me?
For D, ma'am.
Yes.
Oh, it's 5 to the power of 2.
Oh, close. You fell for a very normal trap though, so don't feel stressed about it. Think about your numbers. Stay on the line with me and we can work through together. When we're looking at these numbers, we've got this 2 and we're multiplying that by the 3. So what would that become?
6.
Yes, good. Okay, so that's the N, that's our numbers. Then we're going to look at our V for our variables. We've got 1 A over there and we've got 2 A's over there. So how many A's would we have in total?
3.
Exactly. So that's what our final answer would be. Make sense?
Yes, I do understand, ma'am.
Good. Okay, guys, so let's try something very similar to this. I'm going to do 4xy times negative 2x. Yes, Namonde, you can absolutely answer this next one. This is going to be D.2. So think about it carefully. Be careful with your signs.
Ma'am, it's gonna be -8
Mm-hmm.
x squared
Mm-hmm.
and y.
Yay! Well done. Nice job. You guys are smashing this. I'm so proud of you.
Thank
Goodness gracious. Little brain buffs in this class. Okay, so what we'd be looking at is we have our signs and our numbers. So our signs, we've got a positive times a negative. That gives us a negative. We've got 4 times negative 2, if you want to think about it like that. So 4 times 2 is 8, but if we'd already done our negative. And then we're going to look at our variables. So we've got x and x. That's going to give us our x squared. And then we just have one lonely y, which is going to be our y. Nice job, guys. Okay, we're gonna try something slightly different from here. See how we go. What is my answer going to be? and I'm going to write something very specific on the board. I want my answer in exponential form. Oh, and Paul, I think try and find where it says reactions. It should also be on a Chromebook. Namonde, are you giving us our answer here?
Yes, ma'am.
Okay.
Ma'am, can I ask a question, ma'am? When
Yeah.
you say exponential form, ma'am, what do you mean?
I mean, I need my answer to have an exponent.
So ma'am, do you mean like 2 times 2 times 2 times 2 or something?
No, so that would then be in expanded format. So like if I had like 2 to the power of 2, that is exponential form.
Oh, okay. So ma'am, since I calculated it, ma'am, I got 16, ma'am.
Okay, so you are working out what each of these are, right? So you said that that was 16 and that this was 32.
Yes.
Okay, so that's not wrong. 2 to the power of 4 is 16 and 2 to the power of 5 is 32. But if we're writing it as a big number like that, then we're not putting it in exponential form. Then we're just writing it as a whole number.
Oh, sorry, ma'am.
No, don't apologize. These are good mistakes to be making. But while you're on the line, do you think you can try and figure out how to write it in exponential form?
No, ma'am, it's fine, ma'am. I don't think. Ma'am, it's fine, ma'am.
Are you sure?
Yeah, ma'am.
Okay. Don't pressure. But some of you guys have come into some great ideas in the chat. It's exactly the same. We just have to think about it with numbers. Our base is a 2 instead of an x. So our base is going to be 2, and we're just going to add our exponents. So 4 plus 5, which is 9. So 2 to the power of 9. And if you're questioning and you don't know if you're right, you can put into your calculator 16 times 32 and you'll get 512. And then you can check 2 to the power of 9 will also give you 512. So just be careful that your bases are the same when you do this. Okay. Guys, there are a lot of hands up at the moment. I don't know how many of them were up to answer. So if your hand was up to answer, do you mind popping it down for me? And if it was up to ask a question, then just keep it up. Okay. Fulufelo, how can I help?
Hello, ma'am.
Hi.
I was asking because I used the longer method to get the answer.
So did you write 2 times 2 times 2 times 2?
Yes, and then I counted the answer. So when I'm writing the actual exam, does
Yeah.
the examinator consider that wrong?
No, not at all. You're always allowed to write it out the long way.
Because I understand mathematics the longer way.
100%. And it is never a bad thing to write it out the long way. If that is how you feel comfortable, you write it out that way.
Oh, okay. Thank you, ma'am.
Okay, no problem. Theo, how can I help? Okay. Lolita?
Oh, sorry, ma'am. I forgot to put my hand down.
Okay. Okay, I'm just moving down this list. Melo, how can I help?
Ma'am, how is the base still 2?
So think about it in the same way as when we had x's. When we had x to the power of 4 times x to the power of 5, our base didn't change. Our base stayed as x. So whenever we're doing this, you're just adding your exponents. Your base always will stay the same.
Okay, thank you, ma'am.
Okay, no problem. And Paul, how can I help?
No, ma'am, I wanted to ask the same question as Melo.
Okay, does it make sense?
Yes, I understand now.
Okay, no problem. Okay, last 2, and then we're moving on to the next question. Sibonga, how can I help? Okay. Alita, how can I help?
Ma'am,
Yes,
greetings.
hi. Yes.
Yes, ma'am, what I'm trying to ask you is that should we like simplify it, because it's according to my teacher says we must simplify it. It's important and it gives marks. So here where I see it's you don't simplify, and which means we can lose marks.
What are you meaning by simplify? Are you meaning to then say that this answer is 512?
No, like we must say 2 to the power 4 plus 5. By saying that, you get a mark.
Oh, okay. Look, it's not necessary, but if that
Oh.
is the way that your teacher is wanting you to do it in your class, then absolutely do what your teacher is wanting for you to do, because I don't want you to lose marks because you haven't done that. But when you move into the higher grades, you definitely don't have to show that step.
Oh, thank you, ma'am.
Okay. Okay, guys, I know that there are still some hands, but we got to keep moving because our time is running out. But if you have a question, please feel free to send it to Naliswa and she will help you. Okay, I promise. Can you please give this question a go for me? We're going to try and do as many as we possibly can in the next half an hour. Let me know how this goes. Tell me what my answer is. Think about your bases. And then we can chat. Oh, we have 2 Lolitas. Just try and help out those of you who are struggling a little bit. See if that can help. So just be careful with your bases. Okay, Lolita, we are all yours. What is our answer to this question?
I got x to the 9 times a to the 3.
Beautiful. X to the 9 times a to the 3. Now, when we're multiplying variables like that, we don't even need to show the time. So we can just say x to the 9, a to the 3. But writing the times is also 100% fine. That's great. Nice job. Also, guys, I'm just going to do a blanket apology now. My A's look like 9s. I know it drives students crazy. I try really hard to make them look more like A's, but it's not in me. It's not in me. Okay, if there's anyone who's feeling super lost about this, please let me know. But all we've done is we've looked at where we have the same basis. So we looked at all of our x's, and then we added the exponents together. So we said 2 plus 3 plus 4. So what that would have looked like is x to the 2 plus 3 plus 4. And then we times that by a to the power of 2 plus 1. So we got x to the power of 9 times a to the power of 3. All right. I'm going to give you one more, and then we're going to do a brain break. One more and a brain break. Sure. Icona, how can I help? So you get the 3 by adding this 1 and that 2. Icona, I think I had you and then I lost you. I'm not too sure what happened there. Hello? No. Okay. Okay, last one we're going to try before our brain break. I know it looks scary, but it's actually not so bad. I want you to think about your signs and then numbers and then variables. So I'm going to just highlight things differently. So I'm going to highlight our constants. I want you to think about those. I really like that one. And then I want you to think about your variables. And let me know. Deb is saying, can I help while we have people trying to figure this one out?
Ma'am, I think I just forgot to like lower my hand
Oh,
when I wanted to answer that.
That's okay. Not a problem. Don't worry. Nasisa, how can I help?
Miss, I'm confused by like the first one because like I thought it's going to be 3x to the power of 9.
So where's your 3 coming from?
Miss, I took these 3's that was supposed to be multiplied, and then I said the word 3, and then I wrote 3x to the power of 9 because I added the exponents.
Okay, so just remember when we have our exponents, the base always stays the same. So in this case, we had the x's, they had the same base. That means that base has to stay the same. So it can't become 3x. It needs to stay as x. And this one needs to stay as a.
So you only like add when there's numbers.
When there's numbers, exactly.
Okay.
Okay,
Thank you.
no problem. Okay, I'm seeing some good answers coming in through the chat here. I think I'm going to go through this one myself, guys. I know lots of you are wanting to answer it, but just for the sake of time, I think I'm going to talk about this one and then we're going to jump into our brain break. So for this question, the first thing we're going to look at is we're going to say our signs, numbers, variables. So we are going to look at our numbers and our signs. So we've got 3 times 2 times -4. So 3 times, I'm going to write it out here so you can see what I'm doing. 3 times 2 times -4. 3 times 2 is 6. 6 times -4 is -24. Okay, then we're going to look at our variables. So we've got x's. I've got x, x squared, and x. So we're going to have, there would be a 1 there if there was a number, and there would be a 1 there. So we're going to have x to the power of 4. And then we're going to look at our y's, and I've got 1 y there and 2 y's there. So I'm going to land up with y to the power of 3. Okay. I'm going to move this a little bit. Oh, okay, I can't do that. I'm going to write it out a slightly different way so that you can see what's going on. So the first thing we did was we said 3 times 2 times -4. So those are my signs and my numbers. Okay. Then we looked at our x's. So we had x, x squared, and x. And then we looked at our y's where we had y and y squared. And basically we just simplified it from there. All right. Good. If you guys are getting better, that is making my heart happy. If you have questions, pop those hands up. If your hands are up to answer, please pop them down for me so that I don't waste time by unmuting you. Let's start getting through this list. Okay, Aluta, how can I help? Hello?
I'll be going back to example 1D. 1C, I mean. I still don't understand the one. Because with the previous
1C, this one here.
Yes, ma'am.
Okay.
Because
what
with the previous sums, we multiplied the bases, but like with this one, we didn't multiply the base.
No, we've never multiplied the bases. So think about this one here where we have x to the 4 and x to the 5. We're not multiplying those bases. That base stays the same.
Okay, ma'am, like in number D, ma'am, we did multiply the base, ma'am.
Okay, but those aren't bases. So just be careful. So these aren't bases here. These are constants. They're numbers. So that's like that 3 over there and that 2, they're constants. They don't have a power. They don't have an exponent. They're just like numbers before our variables. And that's why we're treating them differently.
Thank you, ma'am.
No problem. Thank you for asking. Asake, how can I help? Okay. All right, guys. Yeah.
Afternoon, ma'am.
Hi.
I want to know, how do you get the answer of negative 24 x to 4 to the power of y 3?
So the negative 24 is from this first part where we're multiplying all those constants together. So we said 3 times 2 times negative 4. That gave us our negative 24. And then our x's is we have all the same bases with our x's and we're just adding those exponents. And that gave us x to the 4. And then our y's, we have our y's that have the same bases and we add those two exponents.
Okay, ma'am. Thank you.
Okay. All right, guys. We're going to do a quick brain break, and then we are going to jump back into a couple of questions to finish off for the night. But let's jump down to our quick brain break. And I think Teacher Sam also has a joke here for you. Let me just pop them both on the screen. Okay, so the star shown in the picture is made by fitting together 12 congruent equilateral triangles. So congruent means they are exactly the same, and equilateral means all of the sides of the triangles are the same. The perimeter of the star is 36 centimeters. What is the perimeter of the gray hexagon? SNV stands for signs, numbers, variables. Helen, if you don't mind popping your question in the chat for me, just for saving time purposes, that would be great. I promise I will answer all questions that I see coming into the chat. I'll answer them verbally. Yeah, it's a funny joke, right? So, Fulafela, I find highlighting the different variables helpful because then I can see which ones have the same bases. But that's because I like seeing the different colors in questions. It might help you if you are someone who likes to break things up with colors. Yes, absolutely. Please go drink some water. Yes, I see some correct answers coming here. It is definitely 18. So if we worked out the full perimeter of our star, that gave us 36, and there are 12 sides, which means that it is going to be each one of those would be 3, which means that side would be 3. And so then if we have to figure out the perimeter of our hexagon, it's going to be 3, 3, 3, 3, 3, 3, 3, which is going to give us 18. And this joke over here, for those of you who don't get it, if you have the square root of a negative number, it's called a non-real number or an imaginary number. So in maths, we show it with like a little I. So if you ever see a number like this, so square root of negative 100, in maths, we would write that as a little I, as in it's imaginary. It's non-real. It doesn't exist. So if you have a boyfriend or a girlfriend who doesn't exist, you can still rate them. You can say that they are the square root of negative 100. And then people will never know. SNV stands for signs, numbers, variables. It's just a way for us to remember how to break down a question. Okay. Let's jump into some more exponents. Let's see what we can cover in our last few minutes. I think that one's a little bit too easy for you guys. Let's jump here. Okay. Think about everything we've spoken about in this lesson so far. Those of you who are feeling not so confident, I really want you to do your best in this question. And I want you to see if you can find this beautiful answer for me. We will definitely do a spicy one before the end of the lesson. Ah, yes, finally understand maths. Success, guys, success. I promise we will do a hard one before the end of this evening. Signs, numbers, variables. Let's see how many people can get this one 100% right. I'm going to be so stoked for everyone who gets this. Just gonna do some highlighting. Okay. Havana, I don't think I've heard from you tonight. What is my answer to this question?
Ma'am, I said it's m to the power of 6,
Beautiful.
n to the power of 4,
Yes.
and p.
Woohoo! Nice job. Well done. Okay, so this one, the only part of it which was sneaky was those sneaky ones. So don't forget them. If you wanted to write p to the power of 1, you can, but p is it's the same. So p or p to the power of 1, same. Okay. Yay, guys! I feel like we're getting better at these. It's awesome. Nice job. Let's up the spice level. Let's get into some juicier things then. See how we go. Oh, maybe that one's a bit spicy. Let's do a medium spice. Medium spice, and then more spicy. Oh, sorry. How did I get the 6? So the 6 came from saying 2 plus 3, which gave me the 5, plus the 1, which gave me the 6. Okay, medium spice question. Here we go. So we're in medium. We were on like lemon and herb, and then we went into mild. I don't know, this might be mild. Maybe this is mild, maybe this is medium, I don't know. It's definitely not spicy. When you have your answers, check them in the chat for me. I'm trying, Monday, I do see you. I'm just trying to give some love to people who I haven't heard from tonight. Lutando, can you please give me an answer here? Oh no, I can't hear you. I can see you unmuted, but there's no sound coming through. Let's try Tammy.
Hi, ma'am.
Hi.
Okay, ma'am. So the answer is negative 3a to the power of 18 and b to the power of 5.
Woo! A nice job. Solid, 1000% right. Okay, so our numbers, we just had the -3, then our variables, we had a to the 12 and a to the 6, and then we had this b to the power of 5. Guys, solid stuff. Nice job. Are we feeling good with these? I feel like we are feeling good because I'm seeing a lot of the right answers, which is great. Oh no, I'm so sorry. Amacheling, I can only see the top like 4 hands that pop up at a time, unless I'm scrolling, so it's the only reason I'm not seeing your name popping up. But I can't see it up now. No, don't apologize. These things happen. I promise I want to answer your questions. Okay, but remember, if you have a question that's not being answered, just pop it in the chat because that's easier for us to see. Next lesson is on Thursday. So how we got the 18 is we said this 12 over here, and then we added the 6. So we said 12 plus 6, and that gave us our 18. Let's up the spice level. Oh. I would say this is like medium to spicy. You need ultimate spice. I mean, the one good thing with these types of exponents questions is that we can't really get too much spicier than this. It's pretty much all we can do. The thing that makes exponents spicy is when they have all the different laws involved, because then you have to know what to do. But for this one, just think about it think about your 3 magic letters: signs, numbers, variables. Think about your signs first and your numbers. I'm going to lump them together. So I'm going to say that, just be careful. And then think about your variables. And think about what your answer would be. I'm seeing some good things, and then I'm seeing some things where people are falling for my traps. I'm going to give you a little bit more time. Yes, you are still doing exponents on Thursday. You're just going to be doing the second law, which will be division. So today we're looking at multiplication, and on Thursday we'll look at division. Tulithile, can you help me with this answer?
Ma'am, I got 20.
Mm-hmm.
Then m to the power of 10.
Oh, so close.
Ma'am?
Think about it carefully. It's so close.
Oh, 9.
No.
Oh, we plus it by this one here.
Yeah.
Oh, it's 7 plus 3 plus the other 2, so it'll give us 11.
Good. And then what will our n be?
N to the power of 11 too.
Is it 11?
No, it's a 10, ma'am.
It's a 10. Nice job. You got there. That's how we learn. Okay, so let's try and understand how we got this. So a lot of you were coming with the answer of -20, which is a very normal mistake. But what's happening here is we've got 5 times -4 times -1. 5 times -4. Gosh, sorry. Times -1. That's what's happening with these numbers. Okay, and when we have 2 negatives, that's going to become a positive. So that's going to become our +20. Then we look at our m's. We've got m to the power of 3, m to the power of 7, and m to the power of 1. Okay, and then our n's, we've got n to the power of 9 and n to the power of 1. Don't forget these sneaky ones over here. And that's how we get n to the 11, n to the 10. Okay. Guys, do you think you can do one more question in 3 minutes? Do you believe in your ability to do a question in 3 minutes? Tell me yes or no. The winners will win. Oh, I'm seeing lots of yeses. Okay. I see. Medium spice. Medium spice. You got 3 minutes. Give me my answer. Of course. Wonderful. I know technically it's 7, but you have to answer a poll before you leave. So we don't have our full time until 7 o'clock. Nobody, you can always answer. Just put your answer in the chat for me. Let's see. All right, let me see if there's a name that I have not heard from tonight. Who has a hand up? CM Tunda, I have not heard from you tonight. CM Tunda,
Yeah, ma'am.
we're all
my
very
answer-
excited.
Yeah, ma'am, my answer is 24, X
Okay, I like it.
14, Y 17.
And I like everything about that answer. Well done. Nice job. Solid answer. Okay, for those of you who are feeling lost by it, let's try and figure it out. We've got 3 times 4 times 2. That gave us 24. Then we look at our x's. We've got x to the 9, x to the 3, x to the 2. That gave us our x to the 14. And we had x to the 3. Oh, sorry, y to the 3, y to the 7, y to the 7. That gave us our y to the 17. Did we get it right? Tell me how we're doing. Did we get this question right? Are we celebrating? Are we having a math celebration at the moment on that side? Let me know. Woo! Well done, guys. Nice job.